and be able to convert between the unit of moles that we just learned about to mass in grams. So here is just a snippet of the periodic table. You should have access to your own periodic table. If not, make sure you get a copy. We've seen some numbers on here, like we've seen the number 1, +1, or +2 above a group, and that represents the charge of the ions in that group. So beryllium will form a +2 charge, hydrogen will form a +1. We've seen the symbol, and we've seen the name. But something that we've kind of overlooked until now is this number on the bottom here. This 9.012 is going to be known as the molar mass. And that is the mass of 1 mole of atoms. And so for beryllium, if I have a mole of atoms, if I have 6.022 times 10 to the 23rd atoms, its mass will be 9.012 grams. So the unit for the mass of an atom is the atomic mass unit, or AMU. We call that the molar mass, and it's in units of grams per mole, sometimes seen as G/mol, G over mol, or G times mol to the -1st. You might see that in a bunch of different units. So if we see nitrogen here, when I look at our periodic table, this 14 is the molar mass of nitrogen is 14.007 grams. So 1 mole of N is equal to 14.007 grams. Okay? Now, I have some quick practice for you, and we're able to probably do it with some of our periodic table except for osmium. But let's check and use the periodic table to get the molar masses to make sure that you could do this. If I look at magnesium right here is 24.305. And I'm going to make sure I put the units of grams per mole. Fluorine is F. If I look for fluorine F, 18.998 grams per mole. And if I look up or have the molar mass of osmium, if I look on a periodic table, I will get osmium is OS, which is 190.23 grams per mole. Okay? So, we're going to do something with these molar masses, but it's important that you're able to find them. Eventually, what we're going to have to do is we're going to have to get the mass of a mole of a compound. So let's do that through an example of SO3. So SO3 has, if I look up the molar masses of sulfur and oxygen, sulfur's molar mass is 32.066 grams per mole, and oxygen's is 15.999 grams per mole. If I look at the sulfur or sulfur trioxide, or the SO3, there's 1 S atom and 3 O atoms. Now, how am I going to get its molar mass? Well, the way that I'm going to calculate molar masses is I'm going to look at how many of each atom there is in a formula and pretend like I have a mole of it. So look at our steps here. Determine the number of each atom. I've got 1 S and 3 O. Find the molar mass of each element. Got it. Add the molar masses of the elements in the compound. I'm going to add in all the elements. So I'm going to need 1s plus 3o is going to be equal to the molar mass of SO3. I was going to say S molar mass, O molar mass. So let's do that. 1 times the molar mass of S is 32.066 grams per mole, plus 3 times the molar mass of oxygen, which is 15.999 grams per mole. If I add those all together, I have to do this on a calculator, 15.999 times 3, I get a molar mass of 80.063, and don't forget to put units, grams per mole. So this is how we calculate a molar mass. We add up all of the masses of the elements in a compound. I want you to take a moment to try and calculate some molar masses on your own. And in the next video, you are going to get the answers to this, and we're going to learn about how to convert between grams and moles. So make sure you have a periodic table, and I would like you to calculate the molar masses of CO2, NH3, and NH4Cl. Make sure you know this is nitrogen, hydrogen, and chlorine, not CiCl.